Now we're going to talk about a couple of types of quadrilaterals, parallelograms and trapezoids. We start off with parallelograms. Now I've got a parallelogram drawn here, and you'll notice that you have two sets of parallel sides. That's what makes this a parallelogram. Notice this side is parallel to this side, and this side is parallel to this side. That right there is a parallelogram. And what we want to take note of is just some properties of this parallelogram. And by the way, I denote it, this ABCD parallelogram, I denote this way with a little symbol like a parallelogram in front. Okay, so referring to that parallelogram ABCD, what we have here is these opposite angles are congruent in a parallelogram. Okay, so we've got these opposite angles are congruent right here. And in addition to that, the opposite sides are congruent. Okay, so this side is congruent to this side, and this side is congruent to this side, and the opposite angles, as you can see, are congruent as well. Now, consecutive angles, this angle and this angle are supplementary. So this angle and this angle are supplementary. This one and this one, this one and this one. Okay. And you can prove all of this by going back and remembering parallel lines cut by transversal. See, we have parallel lines here cut by transversal. Here we have parallel lines cut by transversal. So you can go back and piece all of this together. But remember, consecutive angles are supplementary, okay? And then you can get other properties just from looking at what I've drawn here and how I've labeled it. Okay. Now, notice I've got a parallelogram here. And note that I've drawn diagonals. Okay. And this brings to light another property that parallelograms have. If you draw the diagonals like this, from one vertex to another, each diagonal bisects the other diagonal. In other words, it cuts it into two equal parts so that this little segment here, that little segment is congruent to this segment here. Okay? This segment here is congruent to this segment here. So diagonals of a parallelogram bisect each other. And rather than write that out in words, I just simply labeled it here. Okay, so let's look at this parallelogram right here. And we've got some things here that we want to try to figure out the value of. Okay, now notice that we have this side and this side. This side is 2c and this side is 22. Well, we know that because these are parallelograms that 2c is equal to 22. And that means that c is equal to 11. Okay, that's something we know for certain. Also, we know that diagonals bisect each other. So if this side is 15, then this side over here is 15. Or if that segment is 15, then the segment where A is 15. So A is equal to 15. We know that for certain. Okay? Okay. Now, we also know that, well, I guess that's all I need to do there. Although you can see that we've got, we could go further with this. Notice that you've got 31 degrees here, and this is a parallel line. This is another parallel line. it's cut by a transversal, okay? So if that's 31 degrees, then this over here is 31 degrees as well. And this one right here, this is 18, so this one here is 18 degrees. Okay. So I guess on the one hand, I was using this parallel line cut by this transversal, and I had alternate, I had alternate interior angles, okay? And then I was using this parallel line cut by the transversal, and I have alternate interior angles on that one as well. So that just shows you how we can use part of these properties. Now, as far as if I want to find the area of a parallelogram, well, notice that I have a parallelogram drawn here, and what I've done here is I've extended it out. I've extended the side out to make a rectangle a rectangle. And now we know how to find the area of a rectangle. It's just the length times the width. So for this particular one, I'm wondering, is the area still going to be length times the width? Well, if you look down at the length down here, it's AD plus X. Okay, so we've got AD plus X. And then if you go up this way, that's the height. So I'll just multiply that by H. Now what that's going to give you is, that's going to give you this big rectangle right here. And you might say, well, that's not the area of the trapezoid, the parallelogram, because we've got this extra. We've got these two triangles. So let me just subtract those off. I'm going to subtract off both triangles, which is 1/2 base. Okay, so the base right here times the height. That's one triangle. Let me subtract off another one. Okay, so I subtracted off both of those. Now let's see what we got here. We've got ADH, just distributing through there. Let me put a times sign here. Plus XH minus, look, 1/2 and 1/2, that makes 1, so that's minus XH. So what we have is the base times the height. So see, it's just like a rectangle, length times width. Okay, so you multiply the base times the height, and notice the height here is something that we might have to calculate. Okay, now let's calculate the area over here for this parallelogram that I've drawn. Now notice that this I've labeled this 30 degrees. Okay, if that's 30 degrees, then this over here is also 30 degrees. And remember, the side opposite the 30-degree angle. So this is a right angle here. So this little triangle over here is going to be a 30, 60, 90. And remember, the side opposite of the 30 degrees is 1/2 the hypotenuse times the square root of 3. So that's that height right there. Okay. So if I want the area of this parallelogram, I'm going to take 5 times the height. Yeah, and there it goes. Base times the height. And I had to calculate what the height was there. Yeah, okay. Now, let's look down here at, I want to show you a trick. Let's suppose we've got a parallelogram, and we've got it in this form right here. You're looking at the graph on a grid, and here you have a parallelogram. And notice that this parallelogram has one parallel side coming out here, and then it has the other one coming out from the origin as well. So you have these two sides of the parallelogram. They're starting at the origin and going out to this one 2, 5, and this one 4, 1. And then, of course, this side is parallel to this side, and this side. But all I need are two sides of the parallelogram like that. And I can do this trick called, it's using the determinants. And what I can do is I can take this point and write 2 and 5 here. Notice I stack them up as a column. And then I take this point right here and stack them. And then I do this. I do a little cross multiplying. 2 times 1 minus 4 times 5. So I've got 2 minus 20, and I get negative 18. Now, notice I've got the absolute value symbol here. So that area is going to be the absolute value of negative 18, which is 18. So that's another way you can get the area of a parallelogram if you are just given the graph like that. And it comes from the origin. So, okay, moving right along. Now we'll look at rectangles. A rectangle is a special type of parallelogram. And what makes it special is it's got 4 right angles. See? So it's a parallelogram with 4 right angles. Now, when you have this situation, when you have a rectangle and you look again at these diagonals, the diagonals of a rectangle are congruent. So AC equals BD. Now, these diagonals still, they bisect each other. They're parallelograms, so you still have that. These are bisected. However, all 4 segments are equal. So this diagonal has the same length as this one. So AC is equal to BD in measurement. Now, if we weren't talking about measurements, we could say AC is congruent to BD. But I left off the little mark above it. That means that's the measurement. Okay, so that's a rectangle. Now, the next thing I want to look at is a rhombus. And a rhombus is a parallelogram, but it has 4 congruent sides. Okay, so now we've looked at a special type of parallelogram, a rectangle. Now we're looking at another special type of parallelogram, and that's a rhombus. And what makes it a rhombus is it has 4 congruent sides. It's a parallelogram with 4 congruent sides. Now, I've not said anything about the angles. It's just got 4 congruent sides. Now, if those angles happen to be right angles, so if you look here, if this, and this, if these are all right angles, then you know you've got yourself a square. So a square is a rhombus. And what makes it a square is that all the angles are right angles. And in a rhombus, we don't know. We don't know what these angles are. However, we do know that, the opposite angles are congruent here. Okay. So we have that. And we can look at the diagonals of a rhombus. Just note this, that in a rhombus, the diagonals intersect at a right angle. Okay? So in a rhombus, this happens. And those diagonals bisect the opposite angles. Yeah. So the diagonals intersect at a right angle and they bisect the opposite angles. Okay, now trapezoids. A trapezoid is not a parallelogram. A trapezoid, rather than have opposite sides are parallel, it has exactly one set of parallel segments. Okay, so this is a trapezoid. Notice this leg, this and this are not parallel. However, this here is parallel to this. And we call the parallel sides, we call those the bases. And we call the non-parallel sides, we call those legs. So in a trapezoid, we have a base, parallel to a base, and then we have legs here. Now, if these legs are the same length, we call that an isosceles trapezoid. Okay? And with an isosceles trapezoid, we have this situation. The angles, and these right here, these are called base angles, okay? Because they're down here with the base, okay? The pairs of base angles are congruent in an isosceles trapezoid, not in general. So this angle here and this angle here, two base angles, they're touching this base. They're congruent. This base up here has its own base angles, and those are congruent to each other as well. So we have a base with its base angles being congruent. We have another base, its base angles are congruent. And that's for an isosceles trapezoid. Okay? And you have here a diagonal 1 and diagonal 2 coming. And the thing about the diagonals for an isosceles triangle is they're the same length. So diagonal 1 is congruent to diagonal 2. This length and this length are the same for an isosceles trapezoid, not in general. Okay. Now, I want to talk about a couple more things. The area of a trapezoid and also something called a median of a trapezoid. But if you look at just a trapezoid I've drawn here, and it doesn't have to be an isosceles trapezoid, but let's suppose we want to find the area of this trapezoid. Okay, so I want to just look at this, and I'm going to draw another little trapezoid here. Okay, so I'll just draw a trapezoid, and I want to see if I can figure out how to get the area of the trapezoid. And I've got base 1 up here, base 2 down here. And I want to do this. I want to draw a diagonal across like this. Okay. And you'll notice that I have two triangles there. Now, every triangle has an area of 1/2 base times the height. Okay, so let me extend this base over here and look at the height. Okay, there's the height, and let me put another height over here. These are both the same. Okay. Now, if I want to talk about the area of this triangle down here, it's going to be 1/2 base times the height. And then if I want to talk about this upper triangle over here, it's got a height too. You know, height's perpendicular to the base. So it's going to be 1/2 base, its base is B1, times the height. Now, dig this. If I factor out that 1/2 h, I get B1 plus B2. Look at that. That's the area of the trapezoid. Now, another way to look upon that is the height times the average of the bases. But that's the formula for the area of a trapezoid. 1/2 the sum of the bases times the height, or the height times the average of the bases, however you want to look at it. Okay, now I want to talk about something else. I want to talk about the median. Whenever you have a trapezoid, and I've drawn one here, I've got a trapezoid, and I've drawn it on a grid, and you've noticed you've got some points here, okay, where the vertices are. And what I've done here is I have calculated the midpoint between this point C and this point A, okay? And I've done that right here. I've taken the average of the x's, 2 plus 1 divided by 2, getting the midpoint, the mid-x, and then the middle of the c's, 6 plus 2 divided by 2. And I get this point right here, which I plot here. Now I do the same thing for the midpoint between 5, 6, and 6, 2. I'm just getting the average x's and the average y's. And I get 11/2 and 4. Now, I connect those two. That right there gives me the median. We call that the median. It's the middle line. It's right there in the middle. And notice that this median is going to be parallel to both bases. That's one thing to take note of. But also notice this. If I calculate the distance from E to F, I use my distance formula, I find that the distance is 4. Now, if I calculate the distance from A to B, or I could just count it, 1, 2, 3, 4, 5. And I calculate this, 1, 2, 3. I could use the distance formula. Notice that 5 and 3 add up to 8, and that's exactly twice the median. Well, that's a property of these trapezoids. The median is always 1/2 the sum of the bases. Okay, so if you've got a base that's length 5 and another base that's length 3, you know for certain that the median is going to be length 4. It's 1/2. So you can see that here. I've got a trapezoid. Let's suppose this is the median. If the median is 13, then I know that this plus this divided by 2 has got to equal 13, because it's the 13 is 1/2 of the sum of those. So look, I've got 4x minus 10 and 3x plus 8 divided by 2 equals 13. Well, let me get rid of this 2. I'll multiply both sides by 2 and get 26. Okay, so I've got 4, 5, 6, 7, 7x, and negative 10 and 8's negative 2. So then I just solve this and get x equals 4. And that's how you can, work with the median.